as a courtesy to our international guests. So, welcome everyone. May I give the floor to Mr. Carmelo del Valle, Manuel Oliva, responsible for the Calypsoneo project. Has the floor. Okay, thank you very much.
Good afternoon. My name is Manuel Oliva, and I work for Airbus Military here in CASA 2 within the PLM Process and Tool Solution Department in Manufacturing Engineering. Nowadays, we are developing a project called PLM project called Calypsoneo, funded by the regional agency IDEA and CPA Agency 2. And we have other companies working with us, such as the Systems, ARPA, LENSER, Technological Research Center as SEIT, the Polytechnical University of Madrid, and our host, FIDETIA. Today's session is within the framework of one of the targets of Calypsoneo, which is dissemination of the project results and PLM knowledge in general. However, our main target for the project is to develop a methodology using PLM tools from the market that allows our industrial engineers to define, simulate, validate the processes in a virtual 3D environment before they go into reality, they go into the shop floor. And for that reason, we have today one of the main companies developing software, PLM software, which is a Dassault system. We're going to give us their vision of PLM and how can they help us with their solution. And we have T-Systems, which is an integrator, and they're going to show us the experience of how they integrate these solutions within the industry. That's it from my side.
Thank you very much. Then Maria José Escalona, as a member of FIDETIA, has the floor.
Good afternoon to everyone. Thank you so much for staying here. I am representing to FIDETIA. My colleague Carmel couldn't stay here. I would like to thank you your participation in this event. It's the second edition of this workshop. And the school and also FIDETIA are very interested in this relation, this collaboration. And I hope that all will enjoy with the meeting. And just to start with the speaker that is the most important in this edition, I would like to explain two small things about the meeting. Firstly, we are going to give you a list to put your name in the case you want to receive information about the meeting and about the slides and so on. And later, in some days, we will present also the video of this meeting in case you want to see via internet. So please put your name and your information. Thank you so much, and I hope you enjoy with the event. And so at the end, you can have a beer and something to close the event. Okay? Thank you so much.
Thank you, Maria José. Well, my name is, I should have introduced myself from the very beginning. My name is Santiago Mencon. I'm head and responsible for the International Relations Office here in the University of Seville. We deal with most of the international actions delivered or conducted by the university. And I have been entrusted by the rector, the president of the university, Professor Ramírez Arellano, to welcome you to the city for those of you who come from abroad, and to welcome all of you to the event because he thinks, the university thinks, that all efforts put in these days, these endless days of crisis, I hate to mention the word, are welcome. All efforts in order to establish new relations, partnerships, sharing, it's absolutely welcome. So I'm sure this will be a huge opportunity for developing not only business, but also probably work placements, exchange, and so and so. From at the international office at the university, we will be extremely happy to help in any manner to develop any actions, any outcomes, any results of this workshop. And also, I guess it is a time, Thanksgiving time, time to thank all participants of the people who have organized this event. I have to mention FIDETIA. I have to mention the companies that have come to visit us from France, and also obviously the school. This is our school of computer science, where we are right now. And not much more to say. For those of you who have come from abroad, I still hope you enjoy the city. Seville still is a very nice destination, regardless of this current situation we mentioned before. Thank you, everyone, the table. Thank you, Maria Jose, assistants, participants. And on behalf of the rector, let me formally declare open this edition. Thank you very much. Thank you, everyone. Should I go? Okay, thank you.
How can I start? So first of all, so I will try to make the introduction in Spanish. So even if I'm French, I'm coming from France, but anyway my customer is Spanish, so I will start. So no preparation, but anyway we'll do. So buenas tardes a todos. Me llamo David Deschamps, vivo en Toulouse, en Francia. Trabajo para nuestro sistema desde 2001. So I have to change now in English. But anyway, I try to do so. I am responsible for the system of the commercial relationship for Eurocopter Group. So this is a worldwide position. And I am responsible as well for Airbus Military. So this is my favorite customer, because each time I have to travel in Spain, because this is one of my favorite countries. So I am part of what we call the Dassault system largest customers in the world, so meaning EIDS, and I am part of 3 sales directors. We are representing with EIDS the biggest accounts in the world, so not only in terms of our revenue, but in terms of activity. And we have a kind of activity so in Europe, so for Airbus, especially in terms of development for the S350 in Toulouse, in Hamburg as well in Germany. So for Eurocopter, we are mainly working in France, in Marignane, so close to Marseille, as well as in Germany, close to Munich. So the location is Donauwörth. We are engaging as well in Spain for Eurocopter, so not so far away from here. The location is called Albacete. We are engaging as well in the US, in Brazil with Elibras, and for the other, what we call the EADS business unit, we are more engaging in Europe, especially for Astrium, so for space transportation, so meaning the vehicles which are flying in the space, and Astrium satellites, which is flying in the space as well. Let me introduce the team I make coming over there. Arnold Roberto, who is responsible, so please stand up, Arnold. Arnold Roberto, who is, I would say, my technical counterpart for Airbus Military, but he's not only in charge of Airbus Military because he has a huge workload with Airbus, commercial aircraft. Laurent Hirtz, on my right, who is the what we call the DELMIA manufacturing sales director for EMEA. So he's working closely with me for Airbus Military. He's engaged very much with me for Eurocopter as well. So the last one, before starting by the guest, the special guest from Spain. So Thierry Bernouillis. Thierry is in charge of what we call the aerospace engagement for the new experiences that we are developing to address by a new way the aerospace market. So he will be the main speaker with me for the DS session. And the last guest, so this is Nicolas Loupi. So I'm quite very happy to have Nicolas with me because I just asked his participation through a short call. So he told me yes, without any negotiation or blah blah blah. But finally, so this is not. So for me, this is a kind of gift because he's representing Dassault Systèmes in Spain. So this is the general manager of Dassault Systèmes in Spain. It's a very important people. So for us, for DS itself in Spain, but I think that for you, this is the gentleman that you have to contact if you need some engagement with us. So I will give you you have the microphone.
Ok, voy a hablar castellano, me es más fácil que hablar inglés. Yo soy Nicolás Lupi, como comentó David, me encargo para España y Portugal de la otra parte del negocio, la parte de las otras empresas que no son empresas como EDS y empresas lideradas por especialistas. Daros una idea de lo que somos en España. Tenemos oficinas en Madrid y Barcelona, somos unas 40 personas básicamente, y veremos a lo largo de las presentaciones que nuestro portfolio de productos no va dirigido únicamente al sector aeronáutico, sino a muchísimos sectores. Y he visto que en las preguntas que están preparadas para la sesión final, el PLM, esta noción de gestión de ciclo de vida de productos, se aplica a muchísimos ámbitos. Y de hecho yo contestaré una pregunta específica y daros ejemplos reales de donde también para la universidad es muy importante, hay salidas profesionales para muchos sectores desconocidos, desde la gestión de empresas de moda hacia el sector energético, empresas de distribución, además que de los sectores más tradicionales para nosotros, que es el sector aeronáutico y automoción. Entonces, nada, voy a dejar la palabra a mis compañeros para hablar concretamente de lo que nos interesa hoy y volveremos a hablar en la fase final.
Thank you. Muchas gracias. So I will start the physical presentation, I would say. So the main agenda, so I will make the introduction for the both four topics, which are more dealing with how we are addressing the aerospace and defense market for the time being. What we call the 3D experience strategy, which is a new way to engage the market, and especially not only the customer base, so the already existing customer, but the customer that we want to address and which are more using the competition, to be honest. I will leave the stage to Thierry for the third chapter, and I will take back the speech to share with you a kind of short brief about how we are engaging with the integrators, especially in Spain, which kind of topic we are addressing together, And I will finish because we are in a university, so I cannot finish without talking about our way to engage with the academics. And to be honest, regarding this topic, I prepared some foils with the French gentleman who is taking care about the EMES house, and I discovered some very impressive information, especially on the Spanish university coverage that we are doing. So let me start. So I think that if you are already used to engage with Dassault system, you are more hearing talking about some Delia products, some Katia products, some Similia products, and so on. Now, the way we want to engage our customers, so the prospect, the already existing customer for sure, is first of all to make a kind of, and to create a kind of dream with the customer. And the dream we have is to build a strategy with the customer based on the pains, based on the challenge, based on maybe the current European situation. So based on many topics. And the target of that is to, at the end of the strategy that we are engaging with the new customer or the already existing customer for a new program, is to create a kind of message, a global message. So this example is to demonstrate that finally in the 60s we discovered the moon. Maybe in the very close years we will discover other planets. But the idea is to put some dates on when we will discover new planets, but not by a camera or something else, but to create a new shuttle to fly to this planet. And with that, we are making and we are building a message. And the message is not only a kind of advertisement, but this is a clear message on which we are believing all together. So this message for the space is, so I will read it directly. If we take traveling the new rates, how far can we go? It's to go far away. We are used to break all the silo, to imagine some new solution, to imagine some new shuttles and so on, and to create and to empower all the imagination of the engineering or all the people who are working over the project. It's to create something special, and it's very important for us about that. So now, when we are coming back to the reality, so Dassault system is existing since 1981. Okay, we are coming from so Dassault Aviation. This is who is a French company which is developing some military aircraft as well as business jet. So based on that, we have a special link with the aerospace and defense industry. And finally, I will not say that most of or all the aerospace and defense program are developed with the DS technology, but we are close to that, especially on the commercial development, so meaning the commercial airplane. For the military airplane, I think that we are losing most of the customer, but generally speaking, it's a very sensitive industry on which we are believing and on which we are still doing some special effort to go far away. So without taking care about EADS, so we have the capabilities to address the market for sure in Europe, in the US, in Asia, and as well as for the emerging market, so in India, for example, in Russia as well. So basically, it's 30 years that we are addressing this market, and we have a very, very deep knowledge about it. So based on that fact, so in order to start working with our customers, we are still trying to make the exercise to split and to make a kind of groups for the main activities inside the industry itself. So when if I'm starting by the top, and this is what we are addressing the in-services. So in that case, we have more to address what we call the operators, so the airliners, for example, the support, so all the MRO company, the customer services company, and if we have to address what we call the OEM, which are more the manufacturer, I would say. So in that case, Airbus Military will be part of this sector, and we are addressing by a special group, what we call the propulsion, because it is not a special, but this is a dedicated activity, and this dedicated activity this is not the special is not a good wording in English, but we have to address by a special way this sector, and afterward we have more behind the OEMs. We have what we call the suppliers, the sharing suppliers as well, the tier 1 supplier we can call as well. So some suppliers are delivering some what we call major modules, as Messier Doty, who is a subsidiary of Safran. They are delivering as well, and the other part is more for the major system. So they are delivering a kind of general system which is ready to be mounted in the aircraft, for example. And afterward, it's more relating to, I would say, to the standard part, some screwing, some stuff by this way, or some already available equipment, and more for the production, we are talking about the toolings, so the jigs and tools. To give you and to share with you what is the future and how we are considering the future of the aerospace industry. So for the time being, we are talking about 2.5 billion passengers in 2011, and the perspective is to be close to 16 billion of passengers in 2050. So finally, it's far away, but finally, it's not so far away. So in terms of business, for this market, over the next 20 years, sorry, the sector will have to deliver more than 30,000 new planes, which is quite huge, because I don't remember how many planes, finally, worldwide speaking, we are, not we, but the industry is delivering per year, but it's 1,050, something like that, 1,000, yeah. So finally, this industry has a good future, good perspective, and in terms of perspective, regarding this industry, we have to take care about the emerging market. For example, China. so which is not a discovery for, I think, for everyone. So in China, they want to be part of the top 5 of players in the world for the aerospace. They want to be the worldwide leader in space in the coming years, if it's not already done. Russia is coming back to the market. More and more we are talking about India, especially in terms of growing market, and especially regarding the airport to be built in the future. And afterwards, the last topic is more for the Middle East, who wants to be finally the kind of hub to address Asia space, so to and from. For the time being, the hub is more for Asia, is more the Europe, especially Paris, in Frankfurt, or in London. But clearly in Asia, they want to become the center of the move regarding the airplanes. So if I'm going deeper on the aviation sector, if I'm dealing with the major challenges, we are so in terms of DS address, we are talking about 6 main challenges. The first one is how to make more and more finally aircraft, but to manage in the same way the environmental impact, which is very important for our future and for the future of the Earth. The second challenge is, and maybe in Airbus military, they are already faced to this issue, is the manpower. So how to address the manpower to be trained and to be available to manufacture and to build more and more aircraft in I would say in the same space allocation for the time being. So the manpower is linked to the second one, is the rate. So how to increase the rate regarding the production rate and the space allocation on which the OEM will have to manage. I will finish by this one, but how to make the how can I say that? The world expansion is meaning more to take care about the sourcing and the supply chain, because even if the OEM are growing, if the supply chain is not able to follow the growth of the OEM, finally the chain is broken. So finally Airbus military, they will have to deal with their own growth, but the growth as well of their supply chain is very important. And the both last challenge on which we all believe, I think, especially Thierry, is the program integrity. And when we are seeing a delivering program on schedule, on target, and on budget, I think that for most of the OEM for the time being, it's a dream, because it never happened. And for sure, the certification. So when we are talking about the certification, we are not talking about the certification itself, but how to develop with the regulators some new process to assess the certification itself of the aircraft. Okay? So the certification is not only to get the paper, but is to develop between the regulators and the OEM a process to assess that the certification will be successful. So for the certification, the best example is the F-400 military aircraft. Finally, both certification, the civil and the military one, was a nightmare for Airbus military. I think I'm not wrong, but it was not so easy for them. The experience, strategy. So as I said in the introduction, we are not addressing the market by talking about the product. So CATIA, Delmia, SolidWorks, Simulia, Abacus, or whatever. So now the idea is to curate through the experience a full value chain starting from the beginning of the story up to the end. I will explain. Because for me, honestly, for a sales guy, it's not so easy to explain that. Our company. So for introducing this slide, I will be clear, especially for the people that are used to engage with DS. Dassault System is not only the CATIA company. To give you just an overview, so 6 years ago, Dassault System was representing 6,000 people in the world, and starting from now, we are 11,000 people in the world. And if we were only focused on CATIA, maybe we should be 1,000 at the present time, or maybe we should be dead. So please don't take care about DS only with CATIA, especially for a very old Dassault System employee as me, and Thierry, especially Thierry, because he's older than me. So for sure, we have some pillars in the company, and the first pillar has all the software, the editors. We have a huge R&D force. We are a scientific company. We have R&D dedicated to develop and to put on the market, to put on the market some products. But we have some very early R&D organization, which is living maybe already in 2020 or in 2025. They are trying to imagine the technology in the 15 years. So as I said, we are just above the 11,000 people. We are representing more than 100 nationalities in the world. We have one global R&D, so we have one vice president who is taking care about R&D wherever the developers are located. Okay, and it's representing physically 31 labs location. In terms of customers, we are addressing more than 150,000 people, customers. Sorry. We are serving 12 identified industries in 140 countries. So we are not only located in France, in US, and in Japan. We are more or less everywhere in the world. The fourth topic, which is very important for our business and for our future, we are not working alone. We are not addressing our customer alone, because we are working with partners. Partners in different areas. Partners for the university, for the academics. We are working for some. We are engaging customer with some integrators firm, some consulting firm as well, and it's representing more than 3,000, I would say, company in the world that we are working together. So now I will finish by the last in terms of figures and perspective. We have a majority shareholder control, so meaning that the Dassault family is holding more than 50% of Dassault system shareholders. Our revenue is close to $2.5 billion, not euro. And our operating margin is more than 30%. So I will not go through and I will not make a deep dive session of this slide, but to come back to my speech 5 minutes ago. So Katia is over there. So we have SolidWorks. So we have many brands. So we don't have only Katia. We are addressing and we created last year 2 new brands. So Geovia, which is dedicated to the technology for the mining. And we acquired as well in the US NetVibes. We will see, and you will see that in the future of the 3D experience platform, it will be a kind of pillar of our solution. We are serving 12 industries now, due to the Geovia acquisition. And we have 3 main ways to engage with the customer. So BT, so business transformation, it's for the large customer. We have VS, so value solutions. So value solutions meaning that we are engaging with partners, and those partners are engaging directly with the customers. This is the indirect channel. And the last one, the PC, so the professional channel, is the channel dedicated to SolidWorks. We don't have, so to give you an overview, BT is only managed by Dassault system employee with the customers. VS can be both. It can be Dassault system employee and some partners. And the professional channel, it's only partners sales force for SolidWorks. A small story of us. I can say us because I'm not Dassault system. Our legacy. So we started 30 years ago with the 3D design. And I remember some good pictures, especially from Fernando with Katia V3 or V2. We created with Boeing for the 767 program at the end of the 80s, so it was in 89. What the concept of the 3D DMU, so digital mockup, a complete digital mockup validation without physical mockup. So it was made due to the introduction of the Katia before. Okay, I have to talk about Katia. In the very beginning, in close to 96, we started to address the new way to engage with our customer, meaning the 3D PLM. So it's not only to make some validation of mockup, but it is to clearly manage the entire life cycle of the product from the beginning, from the idea, up to the management of this already product when it is delivered on the market. So it was made, so not only with Katia V5, because Katia V5 is one brand, but with Delmia V5, with Simulia V5, due to some acquisition. So it's more related to the V5 release, And now we are addressing what we call the 3D experience platform without this is not taking care is not the wording, but being not anymore focused on the product itself, but being focused on the business process of the customer, being focused on the way to engage, a new way to engage with our customers. And we created what we call the compass. So, why to introduce what we call the 3D experience platform? It's to enable our customer to imagine their own product by being the customer themselves. So it's not only to develop a product, but it's to be instead of their own customer and to imagine what I am expecting from this company, what I am expecting in the future. So finally, our customer, we are engaging with the customer of the customer, finally. And by engaging with the customer of the customer, we are not talking about only how to manufacture by the best way, the best aircraft in the world. It's more, it's clearly another way to engage is, I will give you an example, how to create a very good atmosphere in the aircraft rather than the already addressed and current S320, for example. How to create a new way and a new ambience in the aircraft. How to make more comfortable not only the seat but the fly itself of the customers. So finally we are asking for some new questions. And we are imagining some new products, and we are imagining as well some new way to engage with our customers. And for that, we are not delivering anymore a technology, but we are delivering what we call a business platform. And when I'm saying business, it's clearly we are orienting on the business. Okay? Beside and under the business platform, we have to take care about the integration of the platform with the current, I would say, information system. Okay. But clearly, we are addressing a business platform, and what is very new now is on premises, online, in public or private cloud. Means that now with this new business, business platform, we are addressing the cloud, we are addressing the customer, and we are addressing the customer of our customers. It's clearly a new way to imagine the future. So, last choice for me. Okay? So what means the compass of the platform? We have what we call some quadrants. So the first one on the top is to address what we call the social and collaborative application. How to make collaboration between some different departments. How to share information between not only with our customer but the customer of our customers. The quadrant on the right hand side is dedicated to what we call the information intelligence. And to give you an example, the information intelligence, we are addressing with that the NetVibes technology, meaning the dashboarding, to address what is the maturity of my new program, for example. It's a huge exercise for me. On the downside, we are addressing what we call the V plus R, so meaning the virtual plus the reality. And here we are addressing the content and the simulation. So here we are more addressing the manufacturing assembly simulation, the finite element simulation with a Abacus solver, for example. And on the left, we have the 3D modeling application. And for sure, the 3D modeling application, we are dealing with CATIA, SolidWorks, and some other new brands which are coming as well. I think it's over for me. To be sure that you will have enough time to discuss about the most important of the session. Yeah. We'll try to manage the logistics. Just for you. You're beautiful.
Thank you. Can you hear me? Buenas tardes. This is the last sentence I will pronounce in Spanish. So good afternoon. So I will speak in English, and unfortunately my English is not perfect also, so I will go slowly. So thank you, David, for your very short introduction. So I don't know how much time I have, so please, if someone thinks I am too long, stop me. Okay, so my name is Thierry Vermees. I am working in a new organization in Dassault Systèmes, created 1 year ago, which is called Industry Solution. And the objective of this organization is to define, create, develop, and deliver experience, solution experience dedicated for the 12 industries we serve. So as I am aerospace and defense, I will zoom on the portfolio of solution experience we want to launch on the market for aerospace and defense. Okay? So as Davy explained, Dassault Systèmes is moving from PLM to 3D experience. So 3D experience is, I don't want to come back on what Davy explained, is a new way to at least bring the value to our customer. So instead of selling a set of products, we want to sell something that is more compacted. So we take all the products, all the capabilities that have a role to support dedicated process of an industry, and we pre-package that in order for you to be more, or for us, to be more understandable, and to avoid our customer to make the product by product selection in order to create their own solution. That's a way to accelerate the understanding of what the value is brought by our solution to our customers. So let me show you what is the portfolio of aerospace and defense solution experience. So we are thinking about 8 solutions. So once again, those solutions are a combination of products from multiple brands in order to support some roles, some process that have an interest to work all together or to be integrated in a value stream in order to deliver the value in your process. So I will not go in the detail of each one, because I think I don't have enough time, and it could take maybe 200 slides, so you will be very boring at the end. So I will have a zoom on the 3 first one. Why is the 3 first one? It's because we are launching last year, or they will be launched this year, so that's why we are ready on that. I will have a quick, nevertheless, a quick overview of each one. So the first one is winning program. So winning program is the solution experience to address the early phase of a program, the conceptual design phase, if you will. I will come back on that. Co-design to target is, let's say, once the a program has been launched or when you are awarded to win a program, you have to execute it. That's the role of co-design to target. The product, each component, each part, detailed definition that has to be produced at the end. Virtual test is a solution to, let's say, accomplish the test campaign. Because at the end you have to certify your aircraft, you have to verify that and qualify that what you have designed is compliant with what you have sold or with what you have specified. So you have to manage a bench of activities around the test. That's the objective of virtual test. Virtual rollout is something that you know very well in Airbus military. It's more manufacturing engineering, the digital factory, capability to see, I would say, the digital mock-up for each station, and in order to prepare the production, to be ready when the production is starting, and to be sure that you have a rate, an aggressive rate, and an aggressive ramp-up. Our objective also for virtual rollout has the, when you take a final assembly line, you have more and more to manage a very complex supply chain. And the objective of virtual rollout is to make the manufacturing engineering and the simulation, the definition, the simulation, and the execution of supply chain. Built-in conformance is about to, let's say, make the operation of the manufacturing, so more or less related to manufacturing and enterprise system. License to fly is to address the people in charge to, and the processes in charge to ensure that at the end your aircraft or your product is certified. We know that in the aerospace that's a mandatory activity to perform before having the right to launch the product. Secure global collaboration is something that we want to put on the market in order to help the extended enterprise on a big program, because in aerospace and defense, as the let's say activities are cadenced by program, and for each program you have a huge number of partners, subcontractors, and so on and so forth. All those companies have to work together from every part of the world, so you have to put the right service for them to work and achieve the program objective. And last but not least, it's called constant fleet availability. It's a solution that will come later on. And it's about, let's say, maintenance and support. Okay? So if you have questions at any point, don't hesitate. I want my speech as much as possible clear. So I propose to zoom once again on the three first one. And what I propose to do is not to go in the detail of what is it, but give some idea of why we have created the solution. What is a perimeter solution? Who do we serve for the solution? What are the roles? And finally, through a short video, give some flavor of what are the technology behind in order to be more, as much as possible, concrete. Okay? So winning program. This is the first solution we have launched last year, and the objective for us in Dassault system was to address, once again, the conceptual phase. Sometimes in some companies they call it phase E, or in Airbus I don't know if you use M1, M2, M3 milestone, so it's the very first milestone. And we start to analyze that at the end it's a white space. It's not the space where PLM is too much implemented. And when we make the analysis of the product we have in our portfolio, we thought that we have a critical mass of capabilities that support first the challenge that are really important in this phase. So look at what our customer values the most in this space. Is first is winning more business. Because in some cases you have to answer to a RFX process. You are in competition with others and you have to deliver a proposal as much as possible accurate. And this is the place where you win or where you lose. Knowledge retirement. We have many testimonies, especially in North America, where the workforce, and especially expert engineers that are working in the conceptual phase, are eligible for retirement. So if you are interested, and because we are in a university, if the students are interested to go in aerospace and go in North America, a lot of work to do. In 2, 3, 5 years from now, 50% of the workforce has to retire. So it could be critical in this phase where many skills, maybe for the people in charge to win the programs, are having the expertise in their head. Program integrity, we know in aviation, in space, defense, that most of programs have a difficulty to reach a schedule, to reach a budget, or even to reach a specification at the end. And this is the conceptual phase, are the phase where most of the decisions are taken. So if you don't make the right decision at this moment, maybe you will have very important difficulty to reach the target. System of systems, so increasing complexity scope. So this is where you have the pressure by your competitor, by the market, by the stakeholders to make commitments on specification. More and more commitment on specification, more and more commitment on the delay, and more commitment on the cost. So that creates a lot of constraints afterwards. So based on those four, let's say, big challenges that are part of the beginning of a program, we look at our portfolio and we said, what could we propose to address this concept phase? I don't go too much. So the objective we had, and don't want to redetail what I said, but to address the challenge of program integrity, competitiveness, you win or you lose, functional integration, the complexity, and the manpower. Once again, let's say up to 60 or 80% of the decisions are taken at this stage. And as it is a white space, we think that we can deliver, as a 3D experience or PLM vendor, a lot of benefits for the company. So let's have a look on the solution we propose. So each solution experience is decomposed in what we call process modules. These are, let's say, part of the overall process where some roles or actors are working all together to be part of the success of this process. So in the early beginning, you have people in charge of developing the proposal. Proposal manager, proposal contributor, and so on and so forth. The first thing you are doing also is to define the configuration. At the end, this is what you have to freeze. What is the configuration I want to deliver to my customer? Once again, if it's the right configuration, maybe you have a chance to reach your target. If it's the wrong configuration, you will be in trouble. System threat studies, you know you have a large number of requirements, so a large number of different alternatives or trade-offs to investigate, and then to reduce the possibilities and then select the one that you consider as better for winning. The same for production threat studies. Not only the product, but how you will produce what you want to deliver to the market. Once again, you can lose in the engineering, but sometimes you can win in the engineering, and you can lose in manufacturing. So it's important also to make the same trade studies for production. And at the end, reason to believe is how to give the confidence to my customer, your customer, that the proposal I am developing is the right one. How to be sure that once proposed to your clients, you will be selected. That's the reason to be. So let's show let's say, a very quick demonstration of winning program experience, and I will stop the video for me to explain what is the technology behind each very quick step. So the first process module you want to address is proposal development. So proposal development is really to establish the planning, the master schedule, the resources, the people that we want to delegate to create this proposal. And not only to manage a proposal, but also to, as much as possible, identify what could be the risk, what are the risks that I have to manage later on when my proposal will be accepted. So it's more, let's say, future program simulator that we want to provide. Be sure that once awarded, and we hope you will be awarded in this solution. Once your contract is there, be sure that you would be able to simulate as much as possible the future of the program. So for instance, from risk mitigation. So the technology behind, as you can recognize, is based on the 3D experience platform, and we use mostly the Enovia application to do that. So once the proposal development is working, the resource, it's important to define the, problem with the video, is to define the configuration. So to define the configuration, I mean the configuration is not the management of the change as we are used to talk, but just to decide what is the product at the end. So starting by the requirement, starting by defining the mission. For instance, here you will see it's a very simple example we have in IWT2 system. It's a UAV. And the mission is to, let's say, go over the electrical pylon to monitor the power and to see if the line is correct or not. So it's guided by from the ground, okay? And so you have different requirements such as the endurance, the range, and here is a 3D definition of what could be the mission of such UAV. So you can do a vertical takeoff, vertical landing. The ground is not flat, so you have to manage that. You have to make over, and you go to see and control the electricity pylon and power line. That's basically the mission. So now, what is the tool to make the right configuration? First, generally, you don't start by creating something from scratch. You assemble what you already have done in the past. Oops. I'm sorry by the quality of the video. I don't know what's happening. Okay, let's continue. So, here the configuration definition is about to select. I have already a flight control system. Do I have already an engine? Do I have already the battery, the power, and so on and so on. So I create a kind of Lego, and I assemble them. Then I want to track through very key parameters what are the best compromise I have to find between the different disciplines in order to select the different alternatives. So in this example, we create, maybe it's stupid, that's a system. We are not able to make aircraft, we are only making 3D experience, but we have four alternatives, which looks like the one you see. And the objective now is to define which is the right one. What are the key parameters, the key criteria that influence the decision? So let's have a look on how to do that. So first is about to investigate all those configurations. Let's take one, which look like this UAV. And now we are using another technology, which is called FIDETIA system. It's about system engineering. And now you start by exploring from the requirement and from the different functions that you have to address for the requirement, the different components you have assembled. So you create the link from the function to the component, and we are able to add some information, system engineering information, and not only information but also behavior. So the different aerodynamics, for instance, are modelized in the system so that you can run a simulation. Now, what we want to do is also to manage engineering parameters, for instance, the span, the sweep back angle, the twist angle, in order to see what are the influence of that on one single KPI, which is the drag-lift ratio. Because the drag-lift ratio will drive the performance of this UAV. So the best way to do that is to run an optimization loop, which is described either there by a very simple process flow or simulation flow that, let's say, create a different simulation where by technology of optimization, we have different strategy for optimization, you can drive the different tools that at the end will more or less automatically decide which is the best optimization for the drag lift ratio. So here these are different processes, and the simulation tool behind can be whatever you want. It can be a legacy simulation, it can be something coming from our competition, it can be something coming from Dassault system tools. So it's really a platform to, let's say, integrate the different simulation tools and run optimization so that you can converge very quickly on the right optimum. So in this example, the optimization loop has run, and you see the let's say influence of different parameters on the drag lift ratio. And so you can select which is the best alternative for this KPI. And the objective is really to, I'm very sorry about the, is really to do what? To do more optimization in the same time you have. To do, and to change by an order of magnitude. You can do 2, 3, 4 more simulations with the same resources at the same time. So at the end, the confidence you have in the alternative you have selected is far more important. Another advantage of that is you keep the traceability of why you have selected this solution instead of another. Because remember, for a new program or later on the same program, sometimes you don't even know why this parameter has been selected against another. So this tool keeps the traceability of it. Last but not least, you remember when you define the configuration, we have the capability to modelize different, let's say, physics, so that you can play the mission. So playing the mission is not only a movie like there, but you are really running live the different equations. So So the equation of the aerodynamics, the equation of the flight control, the equation of the telemetry to guide the UAV. And so, what is the best way for you as a reason to believe that your alternative is the right one? So here are, let's say, what we want to address by the solution experience call winning program. Once again, as a takeaway, is the conceptual phase. It's a white space, and we have the technology embedded into this solution to address the proposal developer, the engineer, the architect, the guy, the multi-physics or multi-domain, multidiscipline simulation that at the end create the best configuration. As usually in the system, we prefer not working only in our alone in our laboratory. We want to have a customer with us to create that. So one of the customers we have on this winning program experience is IWT, Space Transportation. So we made proof of concept last year for the ZEST. I suppose you know ZEST, which is the zero emission hypersonic transportation. So it's a mix of an aircraft and the rocket. You know that. And what I have seen has been, let's say, prototype with, I think, good results, so that we are now in the phase to extend that to maybe the new launcher in Astrid Space Transportation. Do we have still time? Okay. If you have questions, don't hesitate. The other solution experience is co-design to target, which is, let's say, more classical solution experience, because we address what we were used to address in the past, which is the detailed design phase. So once you have won the program, you have created the promise, now you have to execute it. So you have to deliver the definition dossier ready on time, on target, on budget. So once again, the objective is to, let's say, identify in this phase, which is design phase, what are the main expectations from our customer? And once again, the more important expectation is the program integrity, because in the design phase you engage your suppliers, a lot of suppliers, you engage a lot of resources, you engage a lot of budget, you engage and you have multiple disciplines, dozens of disciplines that have start from the concept, the configuration you have frozen, and now have, let's say, 2, 3, 4 years to develop this aircraft or this product. And as we know, the time, the number of changes you have to manage, the pressure for reducing the delay could cause a lot of reason to not respect the specification. And that's why it's important in any time to control where you are from your specification. The other challenge is the rate, because in many cases the definition is not mature enough when you enter in production, so that you have a lot of issues discovered at the shop floor that prevent you to have an aggressive ramp up and an important rate. So when we have decided to create this solution, we ask ourselves the three questions that are very ambitious questions, but let's start and let's try to be ambitious. Say how to keep program on schedule, on budget, on specification. How to absorb the multiple change during the long development period with no, or let's say with minimum impact on the schedule and on the cost. Today, as the game is very constrained, there are very few flexibility to absorb new changes. So, and you know that, we know that you have to absorb a lot of changes that have not been predicted in the beginning. And last but not least, is how to get the product definition more mature quicker in order to avoid the late issue discovery and shorter. Those are the three main axes where we sought the development of the solution. So the first thing we've done is, once again, to define what are the roles in this phase that have the goal to keep the program on cost, on schedule, and on budget, and on specification also. So for sure, we all know that the engineering team, the whole engineering team plays a great role. We know also that many other functions are playing a role. And I will describe that. So the first processes we want to address is what we call governance and release, which is about the other function than engineering that plays a role. The program, the contractor, the subcontractor, the configuration manager, and so on and so forth. Program controller. So let's show me a short video, if it works. Yes? Of what is it? So the technology behind is an OV application on top of the platform. And here, the first thing to do if you want to address your target is to know your target. So remember, we defined at the beginning some KPI or technological performance measure. And now we propose to have a kind of program cockpit where you can see the different parameters that you want to follow every day or every week. Today, when you are in a program, we know that you know where you are in the program at some critical design review. I mean, it's sometime every 3 months, 4 months, 6 months. And sometimes you don't know where you are, or you discover where you are during this critical design review. The objective there is to, by let's call it the program cockpit, and through some KPI, to see where you are in your program. Here is an example of the weight. So weight is critical because there are multiple reasons to not respect the targeted weight or estimated weight at the beginning. So what we propose is to be able to measure or to compute the weight based on the definition you are producing every day. So automatically, when you design FIDETIA, calculate the weight. Compute the weight from each individual part to the top level of the product, and you can see the evolution of this weight regarding to a target. And you can, once again, on real data. I mean, it's not a dashboard that is created by different people. You call them, they ask to the engineering team where you are on your weight, and then 1 week after you collect the weight, and you discover if you are on the target or not. Here it's live. I mean, live it could be on a daily basis or weekly basis, and it's on real data. It's not a dashboard created from scratch, it's the inspection of the design. The second thing to do is to, let's say, so we can manage a lot of let's say KPI. It's up to you to define which one. I will go ahead because the demonstration is not very good. So the second thing to do after, let's say, having defined the target and having the capability to dashboard them live, is to bring all the functions that have a role in the program all together. So the first function is a program. contractor, the guys that are in charge of the statement of work. The first thing they have to do is, let's say, to expose what are the statement of work and what are the contract line items. Starting from the contract line item, you are deciding what are the configuration items you want to develop. You know that. And then you are able to create what we call a work breakdown structure. What are the different activities that I have to perform in order to achieve this part of the work breakdown structure? So what you see, or sorry, what you don't see, thanks to the video, is something which is inside our product, the application. And every object are out of the box. So we have integrated in our product things that are related to the industry. The aerospace industry is thinking contractual line item, is thinking configuration item. So after the configuration item, you are able to assign to each configuration item the different design solution you want to do. You are able to manage the configuration on top of that. And then, based on the work breakdown structure, you are able also to manage the different integrated master schedule and integrated master planning. Who is doing what and when? I'm very sorry about the quality of this video. So here you have the work breakdown structure. Sorry, I accelerate because the video is really not clear. And so you are able to manage, once again, the different planning. So today the plannings are, the different activities are sometimes managed in different plans or plannings. Each organization has each on one, they are not integrated all together, so that at the end they are not reliable. Here you have an integrated master plan, where you can mix either your plan, the planning from your supplier, and you can have some report, very simple, that you express activity by activity where you are, what is still to be done, what are the deliverables that have been achieved, the one that has not been achieved, so that you have all the information to decide what still has to be done, based once again on the real data. Because the status of each activity is related to the status of each deliverable. And the deliverables can be any documents or can be the design that you are doing in product. Because once again we are in the same platform. Okay? So, last but not least, once you have done that, you have to assign the resource. So what is important is, have you got the right resource? Have you got creating bottlenecking resource? Have your over-resource, under-resource, and so that you can assign by role the different resources to do the different activities of the work breakdown structure. So this is something that is out of the box in our product, and this is open to, let's be integrated to other systems. For example, the master schedule can be done, can be computed, can be defined by other systems like Microsoft Project, Primavera, whatever, and can be, let's say, imported so that you have the complete view of where you are in the program immediately. So remember, we started by the contract. We have made a contract line item. We have made the different CI, the different deliverable. We see that in the planning. In the next release, we project to have an earned value management system, so in order to estimate the cost also. So that you can monitor where you are in the program in terms of specification, in terms of schedule, in terms of budget. And by giving, through a program cockpit, access by a program manager or any people in charge of, let's say, mastering the program, you give them the capability live, daily basis, weekly basis, on real data, the capacity to take the right decision at the right moment. That's the objective. So, once again, if I am too long, you stop me. It's okay? The other thing is to start by the preliminary design. The preliminary design we want to address by what we are calling the master geometry. Master geometry is to collect all the references coming from the conceptual phase and creating in a preliminary design mockup a reference for everyone in the design. So you have the loft, you have the surface, you have the frame, you have the system installed, you have, and I will see, rules that respect your standard. So for instance, does my electrical system respect the installation rule, and so on and so forth. So that it's released by the conceptual phase, so you can start your detailed design not from scratch, but from releasing what has been created in the conceptual design. Generally, when you start the detailed design, it's new teams, so you start generally from scratch, and each team, each discipline, recreate its own architecture, and that's prone of multiple errors in the future. Let's have a look on an example. Here we have an example of, once again, it's a Dassault System aircraft, so very simple. We don't pretend this aircraft is flying, but you see two things. You see the fact that we have what we call a master geometry behind, which are very simple frame definition, very simple definition of system, the lofting, aerodynamic surface, and so on and so forth. Once again, that's come from the conceptual design. And in front of the screen, you have the definition of the connection of the system each other. In this example, the objective is to create a redundancy system. A transponder, the computer, and an antenna. So to be redundant, you have to create another pathway somewhere. So the objective is to give the ability to, let's say, to non-CAD users, who are not familiar with, let's say, the power of CATIA. And by very simple capacity, based on the definition of the system, to allocate a new electrical system into the space application market. So here you have what we call the DMU for the preliminary design. In this example, you can see what are the connectivity of the system in 2D and the equivalent in 3D. So one block here is an equipment that have a representation, simplified representation in 3D. And each line represents a net. It's an electrical discipline there. And you can have a net allocation to what you see there as the pathway or route. Okay, and the color red here indicate which net had been allocated in 2D and which net has not been yet allocated in the 3D. Sorry. So it's a way to accelerate the connectivity check. Traditionally, the connectivity check of an electrical network is done very late. When you have made the wiring diagram, you have defined the 3D harness, and then you verify. So it's late in the process. Here you can do that very early, so that very quickly you can verify if your connectivity is correct. Not only that, so in this case we have a net that has not been allocated, so we have those two equipment to connect. So we will create a new route, a new pathway. So by a very simple click, people that are not CAD user will be able to create a new net in the 3D space allocation mockup. So I go quicker, that's not very interesting. What is important also is here the fact that the guy in charge of creating this route have gone through a zone, which is probably a zone with important temperature, so that the architect said you are not able as a specification to go through this kind of area when you create an electrical pathway. So automatically the system says that. Because of what? Because what we want to provide is the fact that many specifications you have at the beginning are no more, or could be, not only in the document, but also directly expressed as rule in the system. So that your design is guided. Traditionally, the designer has to read a lot of documents to be sure that what they are doing respects the compliance of the different standards. Here, the system tells for the designer. And it's a very important change because you will give the capability to go faster and to make more, or to make less error, I would say. Okay? So it's very, very important in a system to verify those different installation rules, particular risk analysis, segregation rule, and so on and so forth. So that's the objective. I go very quick. That's the objective of this master geometry engineering. Once again, it's not only 3D. It's 3D enriched by systems. Okay? So once you have set up the governance and you are able to track where you are on your program, once you have be very keen in the way you manage your preliminary design, it's time to go to the different disciplines, the different detailed design disciplines. 3 major disciplines: structure engineering for the airframe. And the objective is to be sure that the different actors or roles, the designers, the guy in charge of the simulation, the guy in charge of the part fabrication planning, the guy in charge of the resource programming are working closely in order to be sure that the parts, the individual parts or individual components fits with their targets. These are weight targets, producibility targets, and so on and so forth. And you have the same for equipment engineering, and once you have done the airframe, the equipment, you have to install the equipment into the airframe and connect them each together. So to transport the energy, to transport the information, that's electrical or 3D systems. So we address that, and the objective is to do that with maximum reuse and with maximum of design automation. If you want to be flexible, you have to be as much as possible capable to automate what is possible to automate. Let's give an example. So once again in electrical, so if you look at the previous demonstration, you have made this space allocation mockup for preliminary design. You have electrified this space allocation mockup. No, the same for the engine. What we propose to do is to take benefits of what has been done in this preliminary design phase, to have the knowledge to automate the creation of the 3D logical definition. Traditionally, to route a detailed 3D harness, it's quite long. And it's error-prone because you don't know if you are respecting the installation rules. So here the system takes the preliminary design and generates the 3D harness with the right diameter, because you know the number of wires that go through this through this science. And then you have to finalize the installation of the 3D harness by the right support. You can also use rules to precise the number of supports, the gap between, the distance between each support, and so on and so forth. And once, let's say, you change the logical definition, the system proposes you to adapt or to synchronize the 3D detailed definition by what has changed in the preliminary design. So you accept or not the change, and the system automatically propagates. So it's an example of how to take benefits of the knowledge that has been done in preliminary design to, as much as possible, automate the creation of the detailed design. And this gives flexibility to designers to go faster and to save time during the detailed design. Okay, another example, I like this example, is on structural engineering, and it's fastener. Why fastener? Because fastener is traditionally a very painful process, because you have a large number of fasteners to create, to define, to install, and to industrialize in your product. So it's typically a process where you have to mix simulation engineer, because this is the input comes from simulation for robustness of the structure. Process engineer, because these are the process engineers that explain all the parts are assembled together. And also for sure designer, because this is them to design the structure. All those people have to work all together. So today the platform, our solution is about to do what? Is able to give to the designer the capacity, to give to the designer the capacity to define rivets or any fixation. Today, those fixations are objects in the database or in the platform. They are not something defined in a file. They are objects. They have their own lifecycle management. They have their own properties. You can enrich when you want. And the lifecycle management of each fastener is decoupled by the lifecycle management of the parts. So in terms of configuration management, it's easier. You can adapt your configuration management to individual fasteners. So that's when a change occurs, because you have line of dozen or 100 fasteners, and when there is only an impact on some fasteners, you can select the one that are impacted. That's very important. So the engineering team is creating the fasteners, either by giving a very detailed definition like that, or only by, let's say, giving a very simple definition or representation. Okay. And then what is important is to start to go to the process planning. So manufacturing engineering in charge of defining what are the different sequences to consume the stage and how to consume the different parts of the product. So now we are able to take into account, either manually, like that, all the fasteners that play a role on the part that you want to assemble. Okay? So it gives a facility to select the fastener I want to industrialize for this stage. Sorry. I go quicker. And then, if I come back to the engineering, I will have some more fasteners to add on this panel, I would say. So I create new fasteners. I can decide fastener by fastener what tip is it? What type of representation I want to add? Once again, when I create fastener, I don't want the designer to create the hole in the parts. Because it's not the designer, it's not the engineering to manage the holes. This is a process that decides where are the holes. Okay? So the engineering is creating the fasteners, and then automatically, in the process definition, as I consume this part, I see, or I can update, what are the fasteners that are taking into account, so that the pre-drill or the drill parts are automatically generated for this process. In this case, the holes are larger than it should be, just for the demo purpose. So automatically, you create what we call the condition of supply. So when you have to subcontract this part to any supplier to manufacture this part, you can add any information automatically. So what is done is when there is a change, as this process is integrated, you don't have to recreate everything. The propagation is guided. And the effort to recreate all the deliverables is very limited. Once again, this is the reality of connecting people in the same platform, using the same object, and so avoiding the numerous translation of object between a whole to another whole. So that's some flavor of co-design to target. I could speak a lot more. I think we are already late on the agenda. Tell me, guys. So maybe I
11 minutes.
I have still 11 minutes to pass? Okay. So once again, we don't work alone for this solution. We have a reference customer, which is Bell Helicopter. This is the first program working with this solution, which is considered on time, on target, on budget, with the usage of co-design to target. And based on the different process module I have described just before, they are using all those process modules. We have also another bench of customers. I don't want to go too much in detail. I would like to have a very quick overview in the 10 minutes remaining on virtual test. So virtual test is a solution to once again address the program integrity and address the fact that when you are doing the test campaign, the objective is to detect what cannot be detected in the detailed design and avoid late discovery and be sure that your aircraft at the end or your product at the end could be certified. Once again, for product going on the air or in space, fault is not an option, failure is not an option. So you know that you have a lot of budget to allocate to test. So today, the objective of this solution is to answer the following question. Because creating a comprehensive and reliable test campaigns is something very complex. So the objective is where to invest, what to invest, and did I get the right return? As you know, the tests are sometimes represented by this kind of pyramid, which goes from the very bottom, which are the tests of the different unit material that are composing the different parts, composing the different assembly modules and the aircraft at the end. The left is real, a real test, and the right is virtual test. As we know today, most of the tests are done real, and you know that it costs a lot. And one of the objectives is to reduce this cost. So the question is, do I have to do virtual versus physical? Do I have to do something top-down or bottom-up or both? which scenario I have to do and when, and how to be sure that I will get the right fidelity for the right objective. Because if I make too much investments to get a very accurate test, maybe it's not so important. So create the right balance. So the value we want to propose is to increase the virtual testing. Why? Because it's cheaper for sure, and it's faster, it's come sooner in the process, it's maybe more comprehensive, more flexible and more durable, because when you have made a physical test, once the part has been broken, you cannot reuse them, you have to restart from scratch. For sure, the objective is not to have full virtual. I think maybe in 30 or 50 years from now, but for the moment, it's just to increase the capacity to make virtual. Make tests more efficient. Why? Because the tests are viable only if when you execute the test, you have the right result compared to the intent you have created at the beginning of the test. The other thing is to set the right strategy. So ensure the best coverage with the best methods. And last is to see, understand, and interpret the result. So once again, this is a domain where, let's say, the PLM is not playing too much role today, and we assume that with the technology we can bring on the market, or maybe we could bring in the future, we could have something that is go to a very comprehensive verification and validation management. So closing the gaps or closing the silo between the program management, the requirement, the design, the simulation, the test, and that's the metrics. So in terms of process, we want to support is first to define the test intent, what I want to test. So and then to engineer the test. What are the trade-offs in terms of cost, reliability, adequacy, and so on. The management of the bench and the test campaign program management for each test. And then either I am real, the physical world, either I am fully virtual, either I am a mixed. I have to calibrate the test. Then I have to execute it, to exploit the result, and make the, let's say, the reverse loop to the testing. You are lucky, this is my last slide. Perfect. So in terms of process modules, what we want to address is, let's say, a framework of verification and validation strategy. So this is, let's say, the workbench or of managing the test. So it's a tool for the test director, the test executor, and so on and so forth. Then it's about to make the test engineering itself, to define the test, define the appropriate material, either physical, either virtual. What are the resources I need to execute the test? It's also to provide, let's say, a catalog of resources to execute the test. And especially when you are virtual, we want to provide a catalog of simulation tools that enable you to make the test, either in more structural, either in more system. Okay? And then, which is more for the future, because here we think we have the technology, here it's more, let's say, for the future. It's about to make the multi-physics simulation, which is to create a kind of DMU for test, where you mix the product, you mix the requirements, you mix the test result, but so it's for people to understand the intent, understand the result, and see how to correlate the physical and the real. And the last one is a fidelity control. That it's about to take as much as possible exploit the result of the test. And once the test has been done physically, to correlate the model virtual versus physical in order to continuously increase the accuracy of the virtual against the physical. That's also more for the future. So here are the next solution experience we want to launch this year around the 3 process modules. Okay, so sorry for maybe to be long. Sorry for the quality of the AVI. I don't know why it's working perfectly. So as a summary and a takeaway, we have launched, or we will launch this year, 3 solution experience. Once again, mixing in a comprehensive way as much as possible the different technology we have from our brand in order to address dedicated people for dedicated process. Not by picking and letting you picking the different brick of our software, but offering a pre-packaged solution that you can deploy. Thank you. We could do a lot of more explanation. I hope it's clear enough. Don't hesitate afterwards to ask any question if you want. Thank you very much for that.
Okay, good. Good afternoon to everybody. I would like to make like my colleagues from the SO and start with the first short introduction of myself in English and then to switch to Spanish. But I think it will not be possible, so I made my whole presentation in Spanish.
So the slide will be in English? The slides, the forms, will be in English?
Yes.
Okay, so let's start from the presentation, the speech in Spanish.
All the presentation is in English.
Okay.
Okay. Let me introduce myself. I'm Miguel Delgado, and I'm working in the PLM area of the systems. It's an integrator of these PLM solutions. And I'm in the Department of Product Design Solutions. These are CAD systems. We are working in the areas of training, of consulting, making methodologies, the integration of these solutions, and also the customization of such solutions. If you integrate some such applications, you often need to adapt the applications to the needs of the clients and to give more functionality these applications. Okay. The Systems is a subsidiary from Deutsche Telekom, and the Systems has international presence in over more than 20 countries. We focus on large corporations, multinational companies, in all kind of industries. This is the automotive industry, aerospace, manufacturing industry, but also public sector and healthcare organizations. We are #1 ICT provider in Germany, and our revenue last year was about 10 billion euros. We have about 50,000 employees worldwide, and about the half of the employees are in Germany. Okay, there are a lot of challenges for companies now, and companies normally, or for their normal task is to generate growth and to I'm sorry, I lost it. Yes, to cutting costs and accelerate the growth are common tasks for business. And today companies stand under high pressure. This is intensified by the actual economic crisis, dependencies on export, and even more and more shorter innovation cycles. There is a demand for increase the speed to respond to these challenges, and in the past a competitive advantage of a company could be secured for several years, but today they have to act fast, or they will be seen themselves facing insolvency. There are challenges related to the new social trends like Web 2.0, mass customization, is the needs of the people to define their own products, mobility, and also social media. This creates an unexpected transparency in global markets. And this change also the role of the customer. The customer has former days a passive role, but now it becomes a more active role, even a proactive role in the product definition and the product development. Okay, based on these current social trends, the Systems has defined 5 core beliefs, where ICT plays a driving role in solving customer challenges. Dynamic net-centric sourcing, collaboration, mobile enterprise, security and governance, and sustainability and corporate responsibility. We think that ICT solutions will give important answers to the questions and challenges in the future. And the Systems core beliefs form our portfolio, our services, and our business success. today's portfolio is already aligned to these core beliefs, but also in the future, our services and our portfolio will be guided by these 5 core beliefs. There is a definition from the Wikipedia about product lifecycle management as the process of managing the entire life cycle of a product from its conception through design and manufacture to service and disposal. PLM integrates people, data, processes, and business systems and provides a product information backbone for companies and their extended enterprise. Okay, but what does this means? PLM is not only the applications that we use during the product development process, but much more. It's also integration in the company. There are things like intellectual property, process planning, augmented reality. They are involved also business processes, time, flexibility, collaboration, mobility, costs, things like management, project, portfolio, and the product. But not only the tangible product, like it could be a car or an airplane, but also intangible products, like an insurance, for example. For us as integrator, also PLM refers to a strategic approach to the management of a product and or its entire life cycle. And this approach includes both supporting IT systems and methods and process and organization structures. PLM is not a closed system or a specific IT solutions, but it is a strategic concept which needs to be implemented through operations and appropriate technical and organizational measures. Looking at the different systems we have in a company we use for product development, if you took the focus of attention of the product, then we would there situate PLM. Like if you use another focus of attention for the customer, for resources, or for supplier, you will find another products that were focused for these things. The development of a product, this is an act of finding the correct balance. If there are some forces and tensions, and if we organize these forces and tensions in 4 quadrants, one for customer, one for technologies, one for external influences, and one for project management, you can imagine the product development or product definition as a spiral moving across these quadrants, and the center of the spiral would be the final product, and the position within the quadrant would be significate the balance that we have reached. The needs of companies demand then to accelerate this spiral and to converge faster. Today we have a less number of PLM software vendors, but their global product offerings are constantly gaining depth and breadth. Dassault Systems and Siemens PLM are the front runners due to the strong combination of current offerings and strategy. Today the level of adoption by companies for this technology, for this strategy, PLM strategy, then we see that mainly the companies are focused to the end user tasks, like CAD or CAM, and these tasks are well adopted and also implemented by the market. PLM software vendors are very focused to develop innovative solutions to change the paradigms in the industry. But the companies have not yet fully adopted the complete PLM concept and the benefits it can offer to them. We have two kinds of reactions by the company, one proactive reaction and one reactive reaction towards the adoption of such technologies. We have different markets in which we can use the PLM. There are the traditional markets, from automotive, aerospace, manufacturing industry, railways, but there are also a lot of new markets where we can use PLM, where PLM can be useful. The public sector, utilities sector, telecommunications, banking, insurances. Nowadays, companies must often react in a very quick way to requirements from the market. And so we think that in the future we will move towards to modify behaviors of investing towards renting solutions. And therefore stands PLM in the cloud. We will offer scalable cloud computing models for today's markets. We will offer collaborative environments that help to define virtually the product and to optimize the complete product life cycle. And this accessible from all over the world and through companies. As we have also experience in the telecommunications sector, we can ensure reliable, secure, and high-performance network connectivity. And the benefits for this solution, we would improve efficiency and flexibility, and we would achieve a real-time interaction and product and project real-time dashboarding. Okay. Industrial MU stands for closing the gap between the definition of the product, what we are doing or what we are producing, and the production itself, where and when we are producing it. It defines the industrial digital mock-up of a product. It is a concept from Airbus. The combination in single virtual environments of all of the installation relevant data, and product and tools definition synchronized with the manufacturing processes. Then mobility and augmented reality. There are also solutions that creates intelligent spaces, and we can offer real-time virtualized information to the user. Here see you an example where you, over the real world, you see projected additional information, the virtual information that gives you additional information. In the picture above, it is from a project we made at SEAT, where you can, you have sugar here from the Google glasses, where you can be guided, using these glasses, you can be guided, or the operator can be guided to in commissioning systems to find the right box for his work. Now coming to some examples. One reference is Lockheed Martin. We make them their PLM implementation. It was an integration of Cataly 5, Cataly 4, Delmia, and Teamcenter. There was the integration and the support of Lockheed Martin and the whole Joint Strike Fighter Consortium. And there we support the specification, the implementation, and the training. At IWT, there's another example for online administration of construction documents. The solution allows about 4,000 users to direct access to more of 600 gigabytes of documentation for construction, bill of materials, and technical documentation from the construction workplace. Another example, this was a customization for Airbus. It was a Category 5 CAL development. It's called Samba Laser, where work instructions were projected, or the aim was to project work instructions on the fuselage of the airplane during the construction work. Another customization for the VW group. There are a lot of rules, and in this example for the naming conventions that affects the models in CATIA, and therefore we built an application for control the names of the documents guided by profiles. Another application is an application for data exchange, but not only data exchange between different companies or to the supplier, but also inside the company. There we define we create process chain adapters, so that in the process chain there are data creators and data receptors, and the data receptor gets only the information that he really needs. This is also a valid tool for IP protection when you exchange data with external clients. You can exactly define what kind of information you give to the supplier, for example. We built also industrial reality showrooms or virtual reality rooms where you can validate processes together with doctors, designers and engineers from different departments. So the benefits of this PLM concept is basically to avoid profit leaks. To avoid profit leaks. Source from SimData, they have detected there were a lot of parts where you can improve the production process or product definition process, like reducing the average time spent to find a part or drawing, to reduce the cost to administer engineering changes, the cost to fix bill of material errors, or to reduce the cost for changes or for rework, so that you can get a better profit from 10 to 20%, reduce the development costs, reduce time to market, and have a better quality. And that's especially by CAD optimization. The development of these, the optimization of these development processes. At CAD we have reached development time reduction of 20%. This was the migration from CATIA V4 to CATIA V5, and also the definition of methodologies to work with this new tool. At another client, Dover, we reached about 60% optimization. There we defined, this was also an integration of CATIA V5, and we defined their personalized methodologies to work with their tools. Another example for Mercedes, we have there automated the process of one big data migration, and we reduced the efforts up to 90% with automated processes. So, about this, what did CERT say in 2005 about the CATIA V5 implementation? What are the key success factors for a new PLM tool implementation? They said it should be always undertake an implementation as a project, that you have to invest in developing methodologies, you have to invest in training, you need the availability of qualified support after the introduction, and you have to define the basis of the information structure at the beginning of the project, and you have also to correctly deal with the communication increase. Okay, and that's all. If you have some questions.
now the time for the room table. As you can see, we are a little delayed, so we are going to make this room table shorter. But in any case, if anybody wants to do any question or something, the chair will moderate the session. Thank you.
Good afternoon. Let me introduce myself. My name is Ignacio Eguía. I'm an associate professor of the University of Seville, and I'm the chair of this roundtable. So I have prepared some questions, and this is the moment. If you have any questions, I think your questions probably are more interesting than mine. So if you have any question to the member of the roundtable, this is the moment. Or I ask. Well, the questions I have prepared are focused on the title of this workshop, which is PLM Solution Under Software Paradigm. So we are in the School of Computer Science, and then my questions are focused on these software paradigms. The first questions are about system requirements, and which are the requirements that we need to use the PLM solutions or the PLM systems, and which hardware or operating systems. This is the first question about, I don't know.
Depends on the platform on which one you have to work. So on the last that was presented today, so we use Windows Server 2008, Linux, and I don't have all the detail, but this is the platform for the server. And after you use a lot of other modules like for the database, Oracle or SQL and so on. So I will give you all the data if you need. We have all this kind of information on our portal, and you can access and have all this kind of information.
Well, I think nowadays you can work even with a laptop and start PLM even if a laptop of any mobile device. This is the beginning. It's not like in the past, 20 years ago, where you have to make a big investment in hardware and also on software. But nowadays it should be no problem.
Yeah, we used to have the company years ago a big mainframe just to run CATIA. From that we went into workstations under Unix. They were still expensive, less expensive than a big mainframe with more functionalities. And nowadays we are using PCs, which is much less costs. That doesn't mean, that doesn't mean that the requirement for the information system is something simple. Of course, you can start with something simple for a small project. PLM is going throughout the whole company. So if you want to have the whole company into a PLM system, you need a very complex infrastructure. Starting from the three typical levels, from a database, presentation to the user, blah, blah, blah. Very big system.
If you need information regarding all prerequisites, you can directly go to our website, studios.com, and on this website you have a support panel, and in this panel you will find all information.
So last also comment I can say is that more and more the PLM will go on the cloud. Okay. as other systems. So I don't know for aero because confidentiality is, but for many situations, cloud is now an option for PLM.
Okay, thank you. The next questions are about software and how a software engineer can work with PLM systems. PLM current solution can be considered closed for software engineer. Is that feeling true? How can this kind of PLM solutions be customized or even extended using software solutions? Could a software engineer extend, improve, customize, or even reprogram a PLM solution? Okay, about this same.
So the target is not to reprogram and renew what we provide. The target of the solution that we present today is to cover, I would say, for the big customer, 80% of the needs. And of course, because we have to integrate this platform in an existing environment, we have to develop and to connect, to integrate the legacy and some other applications like ERP. So you have to develop and to adapt the platform. We are providing a platform to develop some dedicated applications that we are not able to develop, or we don't want to cover this kind of market. So it's not a closed platform, it's an open platform to give all the API to develop your own application if you want.
By the same way, we can develop some business applications on top of our solution. For instance, if you have a dedicated business, I don't know, we are discussing about fastening process to build the parts and so on, we can develop with our CA solution. CA solution is very close from C++. As for sure you know this kind of language. And with the CA, you will open some APIs, and we use these APIs to connect with our solution, to connect with our platform, to connect with the studio experience platform, and so on.
Yes, of course, there are many possibilities to work in this area, and there are also a lot of work to do, because there are many specific for any company or for any department who needs a special customization. Also integration with different solutions, with different machines. I think it's a very interesting area, and there is a lot of work to do.
So if the question was, how can my students, which are graduated in software, it's a candidate to join the community of PLM, definitively yes. For the different answer. My case, I am a computer science graduated, so you can do a career in a PLM vendor or an integrator or some software developer is still important in the, let's say, community of PLM. Not only internally into the system, but to integrate the PLM into the other application on the enterprise, to make some customization, to make some complement the coverage of out-of-the-box PLM by new applications. So we have a dedicated partner that provides soft on top of software. The area is quite not defined, but yes, it's definitely somewhere that your student can go.
The next question is about the use of PLM in other contexts. I think that PLM solutions are mainly oriented to engineering areas, like aerospace and defense or automotive. Do you think it can be extended to other contexts like medicine or fashion industry or other areas? Okay.
Okay, we'll try to answer to this question. As we use in different presentations, we discussed about different domains where you can apply PLM. Yes, in fact, it was born in aeronautical and automotive industry where the need, you can not build a product with a PLM. I guess. Other industry now, to the change in the economy, more competitiveness, a lot of challenge in any industries. For example, I will focus on 2 industries that are quite powerful in Spain, but because they're growing. First of all, fashion business, which is an important industry in Spain. They are facing more competitiveness, they need to grow, they need to go outside, and they need to change their business model. To stop to have 2 collections a year, produce, put in the stores, and wait for rebajas, promotions to sell everything. Now you can see if you go to Inditex, Zara, or there's no promotions, there are a lot of rotations because there is another business model out of that. A single, any kind of trousers are only 2 weeks and they want a big rotation. And for that, they need to be very clever, very fast in managing collections. And 2 collections a year, there are several collections a year. Any kind of trousers have it's a short-term life of products, not like an airplane, which is a long life. It's very short life, you need very fast. You have some dates you cannot miss, and you need a solid tool to manage vendor relations, providers, warehouse, and everything. And PLM is a key element to manage collections, sourcing, and everything. Another domain, which is quite good in there are big companies, big reference companies in Spain, which is the construction. I'm not speaking about real estate, I'm speaking about constructions. I think it's out of the top 20 worldwide companies in construction, 5 are Spanish. And those companies, which are doing 90% of their business outside of Spain, they need to face new competitors, new challenges, and they need to be more productive, to be reliable in terms of budgets, timelines in their projects. And for that, if you look at big companies like Dragados, ACS Group, FCC, Ferrovial, OHL, Acciona, these kind of companies, they still have today a big inefficiency rate, which is between 25 and 30%. That means 30% of the cost of their work is lost due to inefficiencies in the process. And now they are focusing at correcting those figures to reduce to maybe to 20 or 15% of inefficiency. And for that, they need to go to a PLM-like tool in order to be coordinate pretty well from architects, engineering, constructions, providers, the right timing. All metrics need to be coordinated, and directors need to have a dashboard updated to take the right decision at the right moment. And all those industries, it's 2 examples. I dig a little bit more, but you can go to insurance, as it was mentioned. An insurance product has a life cycle. If you speak with a company like Marfre, for example, in Spain, they have delegation in each country. They're not coordinating. Maybe they are pushing the market. One product, for example, a new insurance for a woman who drives less than 5,000 kilometers a year, which is a product for them. Maybe they sell it in Spain, but the tests have been done in Brazil, and they do not have the tool to manage the experience, to check everything, to know if it's compliant with laws, which is a new aspect. Laws are different in each country, and they need some tools like that to compete in this new world.
Well, I would only explain two small examples where we work in other areas. We work for the Sagrada Familia, machining a capital. So we define therefore the processor for the machine. These are very rudimentary machines, NC machines, for the machining of this capital. And also we're working in the virtual reality sector with Hospital Virgen del Rocío. It was a project about surgery, I think maxillofacial surgery.
Finally, the question is about the future works. PLM is a very relevant field. Do you think there is a future for information technologies, engineers, to work and research in this area.
I will start the client. We build aircraft. We rely on these. We build aircraft and we rely on these technologies and these tools for industrial engineers to develop their assembly processes. Of course, we need in IT engineers, just as we told, I said before, it's very complex systems. Then we need IS engineers. They need to understand my requirements and translate that information, that what I need, into the software they're providing. That doesn't mean that we need to contract these people. No, we build aircraft. We have them as a vendor, we have them as an integrator, and we work close together.
So maybe I can add from my customer. Yes, we are working a lot with the customer, with integrator. And what I can see that we have two populations to address the business, because our customer is doing airplane, whatever products, but the way to make a PLM working for the business goes through a lot of, let's say, steps that has been described in the presentation, which is specifying the need, understanding what the business needs at the end, making the specification, implementing the specification, customizing sometimes, and if our customer wants us to have something very out of the box, but you still have to make some adaptation. You have to make integration, and all this community of people are working together with skills going from understanding the business to understanding the software, the application, the technology inside the application, the infrastructure inside the technology, the network, and so on and so forth. So it's a lot of area of, let's say, talents to be grouped all together, coming either from non-IT skills to IT skills. And the key success is all those people have to work together and to understand each other in order to succeed in such deployment.
Yes, I think of course there's a future for working in this area. In my group, we're working together, international engineers and IT engineers.
Well, one thing. I would like to stress out that everyone understands the ERP systems, the company has it. And the company puts a lot of money into it to protect their business, control the financial, control. But this is more than data. This is 3D development, and it needs more than an ERP, and it needs people more prepared for that. So the challenge for the future is big. The space for providing jobs in this area is big. And most of the companies don't have a PLM system, and it is the future.
Okay. If there are any other questions, the members or members of the round table? Okay.
Okay, so just to finish before the final proposal, I would like to thank all the people tested here. I hope you consider it even interesting for your specific area. We have here several students, so I think it's very relevant your words, just to try to get new students in this area. And I would like to thank in the name of the school and FIDETIA all our presenters. We will keep you informed with all the information about the meeting. We have the video and so on. And now I hope you have some minutes to stay with us, some minutes or more, to stay with us in the cocktail at the cafeteria. Thank you very much.